program is ALP. There are use assembly language routine for C programming, as it is already been developed and routine for C programming. Well, it improves the speed and particular function. It also used to manipulate the SRF and memory mapping of input and output through direct of the assembly. The following is the program for simpler interfacing. The latest assemblers and facilitator interfacing with the popular languages were easy by making advantage assembler direct. All interfacing is shown in the next block. Here is a simple program which we are going to understand. Here we have used public my function. This is a function which is being created. Then we are been texting a text which will be shown as an output, that is the code. We are assuming it as a text file. We have taken a small bit of memory that is been showed with the help of the near, and again we have end up the program. While ending up the program, we have to always end it with an end statement, so the compiler or the assembly language will know that it has been going to be an end. The subroutine evaluation and the passing parameter. Passing parameter, that means in every program of assembly language we have to pass some of the parameter in it. We are passing this parameter through the C passing parameter, in which it accepts all the parameter as a stack. That means the last in and the first out. We push and pop to retrieve data from it. Normally, it is a parameter which is in short in number integer. In assembly language, we could use the parameter on our basis. We could use it in a small, tiny, or big manner. While developing the code, we first define it as how many parameter or how many type of code we just want, and we could access the parameter of stack with a simplified or secondary stack pointer, that is BP, or the BP register is used for accessing the information of the stack, or the program heavily depends on the BP BP pointer. These are the common area where we need the subroutine to interface. We are going to now Bhushan will explain you the further slides.
Yes. Hello.
Yes, sir. You are audible, Bhushan.
These are the problem statements that we have to perform first, and this problem steps are that we have to perform. The first step is write a program using assembly language in 808. In this we have to write a program without any error, and the second step is run it using emulator and obtain its output. Now this is a C program or to insert a string. First of all, we have included a header file stdio.h, and then in main function we have declared two integers C and count, which is initially 0, and one string of 1000 characters, and we have taken input from user by using getS. For that we have give one message, print one message that input a string for a user, and then we have taken while loop for we have to we have to eliminate the symbols and other characters from the string. For that we have taken this while loop and if loop. In that while loop we have taken if loop, and then we have increased the value of count and C, and then we have printed the number of special characters in the string by using %d, and we have written the value. Next program. Yes, this is the second C program. In this also we have taken a header file that stdio.h, and in this program we have in main function we have taken one integer number, and we have taken input from user integer value, which is stored in number, and which is accepted by using scanf in the program, and then we have converted it into decimal form, and we have written the value. In this program, we have taken integer value from user and converted into decimal number. And at right side of the program, we have shown the output for integer number and decimal number. Yes, now Akash will continue.
Thank you, Bhushan. In this slide, we will see information about assembly language. This language use mnemonics or opcode to represent instructions. These languages are also machine specific. Next slide, Vishal. Library functions, input and outputs. Function name is input. Argument is string and description. Any string to be entered. Function name output, that returns count, and description is number of special characters. Further slide will explain Chandrakant.
Yeah, thank you, Akash. Here our assembly code, that is our assembly program. Here we use model small that we taken for the tails the assembly. We use for a small model. Then then next is our set directive, which defines the 100h words as the program stack. So we use a stack 100h. Then we define the constant and the program variables in our data as data. Then now we simply means we put the enter the string from users and find the special characters found in it. Since we took here is the 0h is for the move to next output line, and 0dh is just for hexadecimal constant for hexadecimal conversion. Then we have defined the DW, which define the byte size, which is 16 bytes. We use the MOVX, which holds the data, and move to the AX register. Then we use the next DS, which is a transfer the data into the DX. And next one in ES. Next the data will transfer it into the ES data segment. And then we use the age register, which is which used to specify the function to be invoked. Then we terminate. Then we using int21h, that's use this for we invoke the function. Now next we use the string for obtaining the address which arises from the memory addressing mode. Then next compare AL, that is we compare AL to the ODH 0DH in our program. Then using the jump instruction, we switches the CPU to exit the difference in the code. Then we coupling the bytes from the AL to memory location, and we compare the given characters, and if equal, then it jumps and we say that is character found. And here, Vishal, next slide. Here we increment our base registers bx and adding both them, and that's end our program. Here the output of our program. Special. Yeah. Next, I will request to Vishal to explain the further.
Yes, thank you, Chandrakant. In next program, we are going to find out the integer, and after that, integer will be converted into decimal point. The input which we have been taken here are the integers which has to be entered, and output will be shown into the decimal form after adding the decimal to the given integer. As we can see here, it is a model small. That means it's still the assembler that we are using a very small bit of the memory to do this program. We have used stock 100, which is a segment directory which finds the words in the program and store it in a stock type. We have used dot data, which will define us that we are giving the input to the data. We have used string db10. db is in string which we have passed in it, and which is going to be printed. Then next, in the code segment, we have written move as data, which means that the data it is variable, and it will be hold into the an x. As Chandrakant explained about the move ds and x, the data of ds will be transferred to the x, and len where the string is to be loaded. In the following move ah, in the the output of the string, where in int 21 load, it will load the result of dx. Interrupting to exit will be done by the last line, and hence at last the program will be end with a statement of end main. Here is the output snapshot of our output. In this slide, we have entered 10 as an integer. While getting an output, we get it as a decimal. As you can see, that is 10.10, 10.0. Sorry. Here is the conclusion for our programs. In the conclusion state, we have been inputting the various string. In the string, there are some characters. In first program, we are going to find those characters with the help of the assembly language program, which has been a program in 8086. And in the second program, we have been going to convert the integer into the decimal point, that is the point and the decimal. The following are the references which we have been used. We have used the G4Geeks for making and taking programs, or having and defining program. We have used our LMS system of continuum.
Hello, sir.
Yeah, Vishal, please continue with the second slide.
Okay. Yes, sir.
So your functions, where is the C file?
Sir, these are for the second, that is integer to decimal, sir.
But that program seems to be standalone,
Sorry, sir.
not written as a function.
Sir, we have tried it with the help of the emulator, sir. First of all, we tried with the TSM itself, sir, but due to some connectivity issue due to with my device, TSM could not work with my device, sir. So I decided to work with the emulator of 8086 itself.
Many of the groups have successfully compiled it. They have found out where are you.
Sir, I tried to connect. Means I tried to
I
connect
have
with lots of.
seen the demo. I have
Yes, sir.
provided you the TASM, everything, the PC required for that.
Yes, sir. I have downloaded those zip
That it
files.
is to be installed. No, there
Yes, sir.
cannot be any problem.
I have run all that zip files, sir, but it won't access by my device, sir. It says that
Yes,
operating system was not being supported over there, sir. I have downloaded all the zip files.
operating system, there is no question of operating system. If you are having DOS box, the DOS box it accepts.
Mm, Maybe some other issues, sir.
Are you using operating DOS box or not?
Yes, sir.
Then it does not matter which operating system you have, whether it is Ubuntu operating system or Windows operating system.
Yes, sir. But it shows some pop-up message with that your operating system has not supported or with that.
Did you share that snapshot with me?
Yes, sir.
Have you
I
installed
have,
DOS box?
yes, sir. I have installed DOSBox as well. I have tried it with the DOSBox first. Then when you have given the zip file, sir, I have also uploaded the zip file and unzip it. But it was not working with it, sir.
What is the problem? It has to work.
Sir, I have already shared and screenshot. May I share it again?
Are you on your machine?
Yes, sir.
Open your DOS box. Share your screen. I think you have presentation right. Who has presentation right?
Yes, sir.
Share your screen.
Sir, is my screen
On the
visible?
bottom there is a
Hello, sir. Is my
on the
screen visible?
bottom at the bottom there is a right button. Okay, share with
Yes,
me.
sir. I have started.
Start your DOS box. So which operating system? Windows, no?
Yes, sir. Windows 10.
Windows 10 or 7.
10, sir. 10.
Where you have installed C?
Yes, sir.
Where you have installed your C?
Sir, in operating system, sir, as well. Sir, this message pop out, sir.
To run your DOS box.
Sir, I have not downloaded it. I have uninstalled DOSBox, sir.
Why you uninstalled DOS box?
Sir, it was not working fine with my device, so sir.
Right. From where you have bought your device? Huh? On every device DOS box works. And what is your device different?
I don't know, sir. Sorry.
Download DOS box again.
Okay, sir.
By evening, you show the demo of this particular C program and ASM program.
Okay. Yes,
Okay,
sir.
sir.
Okay.
Go for CIF now.
Sir, where it is been uploaded, sir? Second one.
There are 7 students in your group. 7 students together, you cannot do this.
Sir, I have tried, but some errors are occurred, sir.
You are
Sir,
trying,
you
then there should not be any problem. If other
Sir,
group from
today
your
by
classroom can do it, why you cannot? It's a very simple question. You should ask yourself, if my classmate is able to do it, then why I cannot do it? Yes, Chandrakant?
yes, sir. Today evening, sir, I
Yeah.
will share, sir.
And fortunately, you got one more day to work on it, isn't it? Hmm? Start your CI2 presentation. Just hurry up, start. I have got a meeting.
Sir, it is not uploading, sir.
It is there, no?
Yes, sir. I have confirmed it, but it is not coming here, sir.
It has appeared, no? I am able to see your presentation.
Sir, it is not.
Just
Sir,
move the slide. Huh?
sir, I can't see it here, sir, due to network issue, I think.
I am able to see. See, this is now I have taken back the presentation, right? This is your first slide. Whether all of you are able to see. Now
Yeah,
I am moving to the second slide, third slide, huh? Fourth slide.
Sir, I am
It's already
Vishal,
there.
बोल ना.
To whom should I share the controls?
reshare it.
Sir,
Who is going to operate this slides?
Vishal, sir, Vishal.
So I am
Yes.
giving control to Vishal. Yes,
Is it
you have
is
the
it okay,
control
sir?
now to move the slide.
Yes, sir.
Start.
Yes,
Bhushan?
sir. Good afternoon, sir. First of all, thank you for giving this opportunity to take this, to give this presentation. Here are the group members that we have presenting this presentation. Next slide, please. Here are the contents that we have included in this presentation, that is a problem statement and description about description concept of problem set, that is descriptors, and snapshot spreadsheet and so on. Next, Vishal will continue with problem statement. Sorry, Chandrakant will continue with problem statement.
Yeah, thank you, Bhushan. Our problem statement is that given a list people to find out the base address, the limit code, and data segment, etc. Vishal, here are the snapshot of the Excel sheet. Can you zoom it, Vishal?
Is it visible?
Yes, it is visible. Here we see that in our the output there are D2 as we convert into the hexadecimal, that is 1101. We taking as D2 of the please Vishal, click on D2. Yeah, here we converted into the 1101 and then D2 as we take as it is. Then next is we convert into 916 to 9 into the hexadecimal, that is 1101, and the C will convert into
Zero. Zoom out, Vishal, please. Here the description of concept in a problem statement. We take as a base address for the segment. Then we limit the length of the segment. P is nothing but the present bit, while 1 is equal to present, and if 0, then it not present. DPL is a descriptor privilege level, which 0 to 3 we have to taken here. Then segment descriptor equal to 0 is equal to system descriptor, and while 1 then code of or data segment descriptor. Then types of the segment we have is there. That is first access bit, that is nothing but A. Then granular bit, then default operation size, which have the 32-bit while 1 and 16-bit segment. Then we have bit must be 0 for compatibility with the future processor, and AVL is the available field for the operating system or user or OS. Yes, we shall continue further.
Following is the concept about the descriptor. A descriptor is selected by an numerical place in the segment register. The descriptor describes the base address, which is the starting address, and the limit, the offset, that means the ending address of a segment. Descriptor also defines the privilege level and access right of a memory segment. As G or an granular byte specifies if a segment length is byte, that's the granular or the page granular. The base address is 32 bits in a platinum class. That address start with a memory segment. The limit is 20-bit number added to the base address to address the last address of the segment, and the limit has to be modified called the granularity, that is G. That will be multiplier of an 4K for a limit, that is 4K is the 12-bit, and 20-bit it will be plus 12-bit in 32-bit. As here you can see that base address is 2300H, and while the limit is 010, for G is equal to 0, and where limit is 0012 FFH, the starting segment for those will be 23000H, and the ending segment will be 23012 FFH. While if G is equal to 1, the limit will be 012 FFH, then the starting segment will be 2420000H, and the ending segment will be 242 FFH. Here is the description summary of the first problem statement. That is the descriptor and the uses of the symbol, that is P, DPL, S, E, ED, and C, RW, and A. Where A stands for the segment or which will be accessed or not been accessed. E, which tells the descriptor about the data segment. When E is 1, it tells data for the code segment. As for the segment descriptor, S1 S is equal to 1 for core or data segment descriptor. DLP for setting the descriptor privilege level. P for descriptor in define, and or for the descriptor based value or the invalid.
And, here is a problem statement B. To design a 8051 based system, the topic we choose is a motion based door opener with a metal detector. And here is introduction about our topic. Motion based automatic door opener mainly aims in opening the doors without any manual help. It is difficult to manually open the doors always in places like hotels, malls, office, supermarkets, etc. We introduce this project which make the door open automatically when the sensor sense the presence of a human being. Next slide. This system works with the help of a PIR, that is passive infrared sensors, and a live body emits some energy. This energy is sensed by the PIR sensors, and the door opens as the energy comes closer to the door and closes as the energy goes far away. This system is enabled of even detecting any metallic object that human is carrying with him and notifies accordingly. We can develop this system further. We can develop this system further by integrating counter mechanisms so as to keep track of the number of people came inside the facility. Uh, the 8051 is an 8-bit microcontroller with 8-bit data bus and a 16-bit address bus. The 16-bit address bus can address a 64K byte code memory space and a separate 64K byte of data memory space. The 8051 has 4K on chip read only code memory and 128 bytes of internal random access memory, that is RAM. Besides internal RAM, the 8051 has various special functions register, that is SCFR, such as the accumulator, the B register, and many other control registers. Next slide.
Yes, thank you, Abhi. This is the pin diagram of the 8051 descriptor. Here, pin which are from 1 to 8, these are known as the port 1 pin. This port doesn't serve any other function. It is an internal pulling up bidirectional output port. Pin 9 is an reset pin. Pin 10 to 17 are known as the port 3, and pin 18 and 19 are for making interfacing with the internal crystal with the clocking system. While pin 20 is providing the power supply to the circuit. 21 to 28 are known as the port 2. 29 is known for PSEN, which stand for the program stored enable. It is used for reading signal from the external program. Pin 30 is an external access input. 31 is for address leaking enable. It used for demultiplying the address data segment to the port. 32 and 39 are port 0, which are the lower order address and data bus signals that are multiplied using the port, and pin 40 is providing for the power supply to the circuit. In the next slide, you can see the block diagram which we have been using for this metal detector. First of all, we have taken on board. First of all, we have taken 8051 series board, which has been connected to the sensor and the buzzer as well as the metal detector. First of all, the PRI sensor will take the sense of an human energy or the human energy which comes from any human. Then it will be passed to the regulator. When regulator pass this energy, 8051 will compute it and tell transformer and the rectifier to open the door motor. As when door motor will be open, it will be detected and the door will be open. Metal detector is for if a person is carrying any of the harmful or the harmless gadget which is made up of the metal, which could be detected by the metal detector. If metal is being detected, it will again point towards the 8051 series microcontroller and it will buzz out. In this diagram, you can see the following connection, how they are being made. First, this is our main board, that is the microcontroller. It is connected to all the devices, that is the metal detector and the PRN sensor. The PRN sensor act as an input which transfers the energy, as well as metal detector also act as an input which detects the metal, and buzzer act as an output device if anything harm or any metal has been specifiedly found into with the person itself. The next slides will be explained by Shubham.
Thank you, Vishal. Here the software and hardware requirement for this project. Here the 8051 microcontroller used to take the input from the sensor and accurately control the motion of the system. Here the PIR sensor which sense the motion around the system, and then metal coil detector which detect the metal, and mini door buzzer which buzz whenever there is a metal detected. LCD display for uh, displaying the motion. Then crystal oscillator, resistor, capacitor, transistor are the suppliers uh, for the suppliers. Then cables and connector for supply, diode are used. Then PCB, breadboards, and LCD transformer adapter, push buttons, switches are on off for the, and ICs and IC stock and software requirement are the Kali compiler for run the program, and MC programming language like C for the programming. Next slide, Vishal. Here the application of this project, motion based door opener with metal. It will reduce the human efforts, as well as the consume less power, and it is used simpler and more reliable for the use. Next slide, Vishal. Here the conclusion for the motion based system. Here the here the conclusion for the first part, descriptor. Here given descriptor we have found out base address, limit code, data segment act, and also we have designed the 8051 microcontroller. And next B part, the motion based system. The conclusion is the system further enhance interfering counting arrangement for keeping record of the entry and exit people in particular place. Next slide. Here the reference we have used in the project, that is Sanjuni Anti-LMS MPMC course, and Greeks for Geeks for the project support. Next slide. Thank you. Here the we are conclude the presentation is over.
Hello, am I audible?
Yes, sir.
Yes, in between my connection was lost. Am I audible? I could not hear any one of you.
Yes, sir. You are audible, sir.
Yes, yes, Vishal. So, just show me the second presentation. To be part. Which system you are design? Which 8051 system you are design?
Door opening, sir.
Automatic door opening.
Yes, sir. Automatic door opening, which also detect the metal, which I also use as a metal detector, sir. Means it detects the metals.
Yes. बघून पण to detect
Which sense where people are coming or not, and also it detect if people are handing any metal or any harmful things with them, sir. Means it act both as a automatic door as well as it scans the people for the metal. Hello, sir. Hello, sir.
Hello, sir. Yeah, sir, present network problem.
Is it sir present, Chandrakant?
Sir, PPT is visible. Actually, sir, when I upload second PPT, it starts with the second PPT. So I deleted the second PPT. After first presentation, I will upload second PPT, sir. Quickly, I have good internet connection. It will be uploaded in 2 minutes only.
Time period. So it's
Aniket,
just for question paper and later on will be
Aniket,
for
Yes,
also
sir.
second PPT also, keep it also ready.
you can use
Okay, sir. Okay, sir. Done with it.
Shall I start, sir? Hello, am I audible?
Yes, you are, but wait for sir call.
Okay, okay.
Yes, group number 5 students, are you ready?
Yes, sir, we are ready.
Yes, you can start now. Turn on your cameras and start. Have all joined?
All I have joined, sir.
Yes, Aniket is there.
I'm sure. Yes, yes, everyone is there.
Hurry up, turn on your cameras. Shubham is visible. Mayuri is there. Maheshwari. Sandeep. Check your audios, all of you. Sarthak. Who is one more? Only 6?
Sakshi is there.
Where is Sakshi?
Sakshi, start your camera.
Okay.
Yes, sir.
Yes. Is my screen, my full screen is visible or half screen is visible? Presentation. First presentation is visible or not?
I hope the presentation is visible. No?
Hello. Hello.
Yes, what
Am I
happened?
audible?
You lost the control.
Sir, automatically get disconnected and again join, sir.
Okay. Now the control is with you.
Sir, your voice is breaking.
Am I not audible?
Yes, sir. Now you are audible.
Audible, sir. Okay, start your presentation.
Shall I start, sir? Audible? Hello? Am I audible, sir?
Yes, Sakshi. Yes, you are audible.
Shall I start, sir?
Who is going to start?
Okay.
Yes.
Okay. Good afternoon, all. Today we are going to present CI activity first on microprocessor and microcontroller. This is my team members. Now we see content of CI first. Go to next slide, Anik. Okay.
I am not able to go to next slide, sir. That option is not there. Yes, now it is there. Yes.
Is there any problem with your device?
No, sir. But sometimes what happens, it says the connectivity issues and disconnected and again join, sir. But now it is okay, sir.
Proceed. Sakshi was presenting.
Yes, yes. Sakshi, start.
Sakshi, unmute yourself first.
Now I am audible, sir.
Now that you are unmuted, you are audible.
Okay. This is the content of continuous internal assessment. First of all, we see a problem statement, and after that we see this intro of interfacing C program with assembly language. There are some now we see there are some steps on program development. Now we see C program which we develop now, and some library functions. First library function first input and their outputs. After that function one code and the result as a snap, and after that we see library function 2, their input and outputs. After that their code and their result, and in this as a format of snap. After that we see the conclusion. Go to next slide. Now, the problem statement. Develop a library in 8086 primarily assembly language for following operations to be called from C language. Write, help, and suitable C program to use this function. We compute this program by using following function, that is concatenation to string and display an integer as a binary number. Now, here is the intro on interfacing of C program with assembly language. In that, we first of all we see why to use interfacing of C program with assembly language. There are several reasons to call an assembly language routine from your C program. We have assembly code already written that you wish to use. Next, if we need to improve the speed of particular function, and if we want to manipulate SFRS or a memory map to device directly from assembly. Now, simpler interfacing. Now the latest assembler provide facility to interfacing with popular language very easily by means of advanced assembler directives or other way. Older interfacing is shown in next block. Now we see subroutine invoke 086 assembly. Now we see passing parameters. So as we know, in a high-level language like C pass parameters on stack. As we know, stack is a data structure, one of the type of data structure. Because of high-level language, because high-level language uses memory in different way. A common areas is needed for subroutine interfacing. That accepted standard is stack mnemonic, which is used to store the data, and which is used to store data. In stack method, data is stored by push or pop to retrieve the data. As we know, if there are if value will be like in numeric or numeric, and parameters are like numeric form or integer form, then that value will be pushed on the stack. And if parameters like operator or operator or alphanumeric string, then it will be popped by stack. X. Now, go to next slide. Now, concatenation of string. This is the process of appending one string to the end of the another string, in which means it means in this process we add two strings together. We use this
Yes, what happened? Rejoin your audio, Sakshi, or someone other can continue.
Yes. Good afternoon, sir. First problem statement is a concatenation of string. Concatenation is the process of appending one string to the end of another string. You concatenated a string by using the plus operator. For string literal and string constant, concatenations occur at compile time. No runtime concatenation occurs. Then example, the best way to describe when you take two separate string, store by interpreted and merge them so that they become micro string. First string is micro and second string is processor. These two strings are combined. Then one is there is microprocessor and second is micro plus controller. It means microcontroller. Then next slide. This is a basic step for concatenations, means algorithm for concatenation. First step is initialize one memory pointer source index to the next of last location of the string. Then second step is initialize another pointer destination index to the first location of second string. Then third step is copy the content pointed by destination index to the register. And fourth step is copy the content of that register to the location by source index and update both pointers. If it's 3 and 4 until the second string get copied. Then sixth step is the resultant, and last step, seventh step is reference. Then next.
Who is presenting?
Next problem statement is integer to binary. Means what is mean by integer? Integer is a whole value, positive, negative, or zero numbers are there. Then it is used to if profits are present by positive integer, then losses by negative integer. Then another use is if height above sea level by positive integer, then depends below sea level by negative integer. Then binary number. Binary number are represented in two numbers 0 and 1, which is understood by machine and computer. Then binary number uses in computer architecture, since the computer understand by the language of 2-digit zeros and 1. Therefore, the program is done using the binary number system. Then algorithm and example. The steps of convert to integer to binary. First step is check if the given decimal number is less than 2. If it is less than 2, then the given decimal number is the same when convert to its binary equivalent. Then second step is, if the given decimal number is greater than 2, then divide the given number by 2. Then third step is, note down the remainder. Fourth step is, repeat step 2 and 3 until the quotient is less than 2. Then fifth step is, now note down the remainder from bottom to top. Means if the given decimal number is even, then the remainder will be 0. Then if the given decimal number is odd, then the remainder will be 1. This is example for decimal to binary, 13 base to 10 to binary, and 13 number, it is divided by 2, then 6 is quotient and 1 is remainder. Then another is 6, it is divided by 2, this is quotient is 3 and then remainder is 0. Then and bit is 1. Then 3, it is 3 is divided by 2, quotient is 1 and remainder is 1 and bit is 2. Then another is 1 divided by 2, it is quotient is 0, remainder is 1 and bit is 3. And so 13 to base 10 is equals to 1101. It is binary. Then step in program development. This is step for program development. First step is, first write assembly routine which is compatible with C. For example, program underscore name dot asm. Then next step is, then assemble the file using tasm assembler. For example, tasm program underscore name dot asm. This is create file called object file dot obj. Then next step is link the program using command line. For example, t-link program underscore name dot obj. Then next step is, this result in working .exe file. Then next step is, in order to study the .exe file in detail, first suggest to use either TD means turbo debugger or TCCS option. TCCS program name .c produce assembler output of the C program.
Yes, I want to add more on this. If our debugger is our C program is in GCC or TCC, with the help of -s option, we can get the whatever the assembly program for that C file is there. It will be generated in one another file using TCC -s, or if you are using the Linux, then GCC -s and then the program name. It will convert that C file to an assembly equivalent code. So you can process further.
Then next is assembly language. These language are mnemonic or opcode to present instruction. Mnemonic, it is that can be remembered comparatively easily, and that adds it's using the recalling information. Mnemonic, it is used in computer programming and communication system operation. Then next is, this language are also machine specific. Third is low level language, that is instead to communicate direct with a computer hardware. Then next is, it is very high speed language. Then higher level language like C++, Java, Python, but its syntax are not that much reliable as of high level language. Then next slide is represented Aniket.
Okay, now we are going to study the C program and the how we take the assembly program in a C program. So first of all, this is the C program. In that C program, first there are two functions. As we have two statements, we have two different files. So in first one, we have to concatenate the string. So here we have included the header file, then void main, and then here we have called the concat function, which is defined in assembly language. As we can see, in C language, there is no such inbuilt function named concat. So it will get it from assembly language, where we have created that assembly program. And in the last, getch is the inbuilt function of C with the help, and it will take the one character from us to terminate the program. And in second one, the second statement is our to decimal to binary conversion. So in second one, we have included two header files. First is stdio.h and second one is conio.h. Here the same void main is there, and in that we have declared one variable, that is a decimal. And we have, with the help of printf statement, which is in C language inbuilt, we have displayed on the screen that enter decimal you want to convert. The decimal you want to convert, user will enter that decimal, and that will be taken from the computer system, that is C program, with the help of that scanf function, which is in C program. So with the help of, as it is an integer, we can use %d, which is the syntax in C program, and we will store that address at means whatever the user will enter, that will be stored at the address of dec, that is our variable. Now we are going to pass the parameter in which is we have calculated, we have taken from C program to that assembly program, which the function is bn. With the help of that function, we have called the assembly program procedure, with the parameter we have passing dec, which is taken from that user, and at the last we are getting getch, which is used to get the character to terminate the program. Now in the next slide, we are going to study the library functions we have used. In the first one, we have used that concat function. There are no parameter passed there. If you can see in that program, you can see that there are no programs, means no parameters are there passed, but we have taken the input from the user in assembly language itself. So what we have did, we have gone for variety. We have taken each and everything which we can do. In first, we have taken no parameters. In second, we have taken parameters. In first, we have taken the user input in assembly language. We have taken their in second program, we have taken their user input in that particular C language. And also there are many more, we have variety, so which we will discuss further. In the output, it will return the concatenated string on the display screen, which is our output. So in the next slide, here we have declared one macro for our program. There are 4 macros in our file. That is, the file name is cia.h, as the macro is always saved with the .h file extension. So in the first, we have read character. This is the first macro we have used. It will read the character from the input. So here we use DOS interrupt, which is N21H, which is available with 8086. So first of all, we have used the interrupt N21H, and there we have passed AH to 01H. 01H is for read character. 02H is for DOS interrupt to write, and means to display. And the third one we have used is output with the help of 09H there. And then we have here all where you can see that we have passed one, we have passed that REG, which is we have to display in the DL register, that is data register, to display. In the string, we have passed it to DX register as it is a string. it needs more bytes. So it will be transferred to DX register, and the offset STRADDR, which is the parameter to be passed to that micro. With the help of micro, we will pass that STRADDR, and it will display that string included, and then NDM and that macro directives. Assembler directives are not converted into the machine language. They are just known to assembly routines. It will just use to indicate that it is the start of the segment, or it is start of the macro, end of the macro, or just like that operations. So in the most important macro, we have used this input str to use buffer, and is the DOS function. Get the string from the user, and it will be passed to that DX register. And in 21 here also, here is our program which of macro. So we are going to study the functions which we have developed. So first of all, here we have gone with old directives. In the second one, we go on for the new directives which are present later on. So first of all, we have to include that cia.h file, and then we have public the concat, which is our function, with the underscore, which is the syntax. So with the help of public, it will be access to all the folders, all other documents, and the module will be small. So data segment word public data. Here we have actually defines the data. So it will be access to everyone. If each data is available to all other documents. So first of all, we have declared one string with the bytes, and will be given to that M1. We have declared here M1 DB is defined byte, and 1030 is a sign conventional for that, and it will be display enter first string. M2 will display enter second string, and M3 will miss message third. Here all these are the messages will be displayed on the string to take the user input or to display that input. So first of all, we have here str1 db, which is of size 25. Question mark is the that we are not exactly know the size of that string that user entered, that will be indicated by question mark, and 25 duplicate those dollar signs will be there at the start of when we start our program. It will be there to all except first and second will be of dollar sign. Same is str2 for second string. Here data segment ends. Then as the sign conventional, here by mistakenly underscore is remain, but in our actual program underscore is there. Underscore text segment word public code. So it will be a code segment of name text with the assembly directives. To convert into a C language, it is necessary to have a underscore text segment as a code segment. So here we assume that that code segment is underscore text and that data segment is underscore data. So we are going to move means given that DX register to that data, and that DX register will give those data to the DS. So we are here declaring means defining that concat function. So that concat function will be the procedure far procedure here we have used to call it from another module. So push BP. So first of all, we are going to push that BP, and that BP will be means base pointer will take the stack pointer. Here actually there is no need of that, but for the formality we have given, because we are not going to pass it parameter to that procedure. So first of all, this string which we have used in a macro, this is a call of a macro, and M1 will be passed. So it will be display that string. Here input string will be there, means first M1 message, that is enter first string, is displayed. Then it will take the user input, then display second message. It will take second input with enter second string message, and then h lead means that 0h is for input string. Here instead of using that macro, we are going for direct implementation, that is ah register. 0ah means input buffer. So we are taking the input buffer lead dx str2. So we are moving that dx register, means loading that dx register with str2, and in21 is calling. Then move cl. This is the what we say counter register. It will point to str1 plus 1, that is end of that string, and then that si register will point to str1 at the start. So we have to increase that si pointer and decrease our counter, so that si will point to the last. If when the counter will be 0, si will point to end of that string. So if jnz means jump not 0, if this will effect is that counter will not be 0, then we have to go to next. And if that counter is 0, we have to increase that si 2 times, and then we have to move that di to offset str2. That is we have to str2 that string, we have to take it into di, that is data indicators, its index is there. So we have to increment that di register 2 times, and then we have to go to move cl str2 plus 1. So it will be pointing to the last of the second string, and we have to move this is the label to move next. This will create one loop which we are going to study in next slide with this detail. So we have to first of all the contents that are di register, which is the start of the segment, are there, and that will be, and as si pointing to that end of the first string with that counter, we have taken si increasing, and then at the last point si will be indicating. So that content of that si will be give to that contents of si we are giving al, that is di register, means str second string is there, means second string first character will be given to the first string last character. So here we are appending one by one characters there, and we are increasing si and di, and we are operating. And while we are appending, we are decrementing the count. So when the count will be 0, we are going to loop, which we have we can see in this here. Move next, from move next to this j and z, move next, the loop will be generated. So how many times it will happen? The loop will be for that str2 length, whatever the length of the str2, it will be again and again will be called. Then we have to display the str3, that is third message we have to display first, and then we have to display that concatenated string. So display str1 plus 2, and then we have to pop that BP register, and we have to return, as every procedure has return statement ret. So we have to return it, and then we have to concat end p. So we have to end that procedure with the directive end p. Then we have to end that text. Then another module, another code segment we have declared here to call that this is of no use. Actually, without this, we can also generate the output for C program. Use that assembly tasm to convert that to run this program. We have another code segment which will that call concat will be there. And so it will be at the last exit is there. So everyone knows that 4ch is used for the exit. The DOS interrupt 4ch is used. We have to end that code segment as well, and end start means we have to end that with the help of that end directive. We have to end the program, and these are the snaps. This is first one is for the snap is for how we converted. First of all, we go to C directive mount with the help of mount command. Then we go to tc bin, here set the path and all that, and then here is the actual output. Enter first string, we have given string, second one gives the concat, and it will display the string concat. In the second program, here there is some differences there, as that decimal is passed to that parameters. Here we have used decimal as a parameter. There we didn't use any parameter. Here another procedure is also there, another function is there to declare and use the assembly print the binary number. For printing that binary number, we have used the print, and then inputs are taken by user as a decimal in a C program, and output will be given to that. With the help of that print statement, we are displaying that output. And so here is the program. So here we have used new sign conventions for that, means new assembler directives. It will be very easy with the help of new assembly directive, but for the variety we go on for a different way. Here we just need to dot model small, and we are declaring C to convert is declare of 100H, and then we have public bn, and then dot data indicates the data segment, dot coding indicates the code segment, and it already are in the public mode. So we don't need any other sign conventions for that. So here we have started bn procedure for here procedure we have declared. Then we have to push bp. Here there is the main reason to push and pop. So first we have to push that bp. The bp contain that parameter the bp we have to push and move the sp to bp. So here sp will contain the parameter passed by C program, and that will be given to BP register, and that BP plus 4 will indicate that string which is there, which is the new sign conventions which we are studied. It will be passed to accumulator, that is AX register, and then we have to call that print function which we are going to see. Then move age for ch is same, it will be exit, it will use for exit, and in 21ch is interrupt, and bn and p is end of that procedure. In second one we have to use we have to declare that and initialize, means we have to define that procedure of print which we have called in this segment, code segment. So here we are going to print procedure declare, and then we are going to initialize counter with 0, dx with 0. Here are the steps. First label 1 is there. If that AX register is 0, it will be compared. With the help of CMP, it will be compared. And if that is equal, if the comparison is equal, then we are going to label print 1. If that is not equal, then we are giving that BX register 2. And as we have studied earlier, that Maheshwari has told how to convert that binary. So we are just going to 2, and whatever there is will be there, that will be pushed to that stack, that DX register we are pushing, then incrementing that counter, and then set we are going to use XOR operation. It will set that DX register to 0, and it will be jumped to label 1 which we have already there. This is label 1. It will create one loop until that until the exit condition is there. So print 1, which is label in call in another slide. So we are going to compare that CX register with 0. If that CX register means counter register is there, if our count will be 0, then no need to go further. So we will jump to exit. Then we have to pop that DX register to the top of that stack, and we have to then add DX register to 48, and then that move AH 0 to H. With the help of that 0 to H, we are going to display the character. It is DOS interrupt to display the character, and in 21H there, which is our DOS interrupt. Then we have to decrement the CX register and jump print 1. Here is the print 1. We have to jump, it will also create one loop. Then we have, if everything is there, and when that compare CX0, that is the counter will be 0, that will be exited to this loop, this label exit, and it will return, that is end of that function. It will return that, and then it will end that procedure with the help of NP directive. It will print and then end BL. It will end our procedure, our these are the outputs. Here we have used that path, and then we have TCC, the name of C file, and then the binary.asm, that is assembly file name we are giving. So as you can see here, there are no errors are there, and no error in C file as well. It will not generate any error. If it's generating error, we have to solve those error and again call to that TCC binary one, means the name of that C file and ASM file. Then we are going to here use the executable file which is created by that C file. So here we will go for binary 1. It is the name of our C program. So enter decimal you want to convert. So we have entered 5. It is generating 101, which is the binary equivalent of 5. And these are the various snaps. For 1 we have gone, it takes 1. For 2 it's 10. That is 10. It's 11. All the inputs snaps are there. So these are the 2 programs we have included. First one is have no parameters. Second one is have no parameters. For first one, we go for older assembler directives. For second one, we are going for newer, which is latest assembler directives. From that, we have also studied that the second, which we have discussed, that is new assembler directives are very simple to convert to C program. That is C compatible. There are more C compatible than that of the assembler directive which was earlier. So here these 2 programs we have explained. Now I request to go further. Mayuri, please explain that conclusion. And we
Good afternoon, myself Shirode Mayuri, and I am here to conclude our first CIA. That is, we have successfully implemented the 8086 assembly language program to concatenate strings and to convert integer number to binary numbers, as well as we have implemented, we have successfully made it public and using a procedure we called it from C, and also passed parameters wherever it was necessary using stack and base pointers, that is using BP registers and SP registers. So here we conclude our CI1, now see CI2. Aniket, next presentation.
Hello, sir. Hello, sir.
Okay. You may proceed with CI.
So we have to go for outputs here or after second CI. Implementation and output that.
Demo
Huh?
you can show it together.
Okay, at the last, sir.
Okay.
Or right now I should share.
Okay, you can show it now also.
Okay, sir, I will show it right now. Sir, screen is visible. Okay, I will again share it.
Have you pressed that share screen button?
Yes,
Is
sir.
at bottom right.
Yes, sir.
Now it is visible.
Okay, sir. Okay, sir. I will go for this. Here, first of all, we have to go for mount C : Here we go to C directory. Should I make it full screen? It will be good. Okay. Now we have to go to this turbo C file, then cd. There are bin directories there. So first of all, we have to set the path is equal to C tasm file. First we have to show path, and then for second file, that is tc bin. Here we have set the path. As with the help of this command we can see. And now with the help of tcc command, we have to display that our output. So our name of that first file is test1.c, and the in str is our file .asm. Here we can see there are no errors in both files. So it generates the executable file, which we can see test1.star. Here is test1.exe and test1.exe file is generated. So we just need to call that file test1. So it will enter, it will show the pop-up message that enter first string. Suppose I used MP, the second string will be MC. So it will concatenate those two strings and give us output MPMC. Should I go for more or second one?
So you have called a function, no? In test1.
Yes.
Open the test1.c file.
Yes, sir.
You can open it using Notepad.
Yes, sir. I will open it. But sir, in PPT also we have included that file. Should I show that?
No, I am asking you to do some modification in that file.
Okay, sir. Here in task tc b, and then test1. This is C file and assembly file. I will open it.
Okay, this much is sufficient. ASM file we shall keep as it is. After concat, you add a statement.
Which statement, sir?
Printf.
Printf statement. What should it display?
This should be displayed after concatenation. This.
Thanks. Okay, sir.
Save this.
Suppose uncreate. Oh, actually, it is not displaying that. Thanks. Maybe I saved now. Just a minute, sir.
You have saved it, no problem. But you are
Yes,
not
sir.
called that file as a function. It is not returning.
Means, sir.
It is not transferring control back to the main program.
Okay.
The
Means,
concat
sir,
function is not transferring control back to the main program.
Okay, sir. This is our program, sir. Here we have pop our BP, but why is not? I'm not
See
getting.
what is there before that?
Exit is we have taken earlier. Maybe. Okay, sir. We will.
Exit, that is not at all required.
Okay, sir. It will be outside, na?
No, it is not required.
Okay.
It is a standalone program, then only we write that exit.
Yes, sir. Actually, why I add that exit is that when I run that program without that exit, it was not terminating. It was continuously in that loop.
No, but that is the other problem.
Yes, sir. So
in the functions, the function should not terminate the program.
okay, sir. We will modify it and then we will upload.
That means there is a problem in that function. Okay.
Yes, yes, sir. I will modify that function here. That exit statement I will take in another code segment, and then we will try. And, yes, sir.
One more thing.
Yes, sir.
The strings you are concatenating
Yes, sir.
should be passed by the main function.
Okay, sir. We have first of all we gone for it, but later what happens? We think that we have various options should be there. So what we did for binary, we have passed the parameter. For that, here we have taken it in assembly language itself.
No. See, whenever we are writing function, then you should not expect that that function will input the string, okay? Because the purpose of the function is to concatenate strings, so the string should come as an input to that particular function.
Okay, sir.
So main program will decide whether to input it from the user or take it from some already existing file and concat. That depends on the main program. Okay.
Okay, sir. Sure, sir.
So because here what happens, if the main program wants to input from the user, then the main program can use scanf statement, and then after it has entered accepted, it can pass on to that particular function. But if main program wants to read it from some database and concat would like to concat the strings that are read from the database, then such strings cannot be concatenated by your function.
Go for it, sir.
So whenever we are writing any
yes, sir, we are getting what you
so clear cut what should be the input parameters to that function and what should be the output parameter of that function. So that should be very clear. Okay. So that is why in the format itself I have specifically mentioned that what are the input parameter, what are the output parameters.
Okay, sir.
So if you see any standard library function of C, Java or any other, so they have the standard, they have the inputs and the outputs. Okay.
Yes, sir. We have for this program we have what you say we have gone for same.
In that case, what you have done again, you have taken input, but the output again should be written. So you are not returning the output. So that output is you are directly displaying the output.
Yes, means okay, sir.
If main program needs binary number, then that number is not there with the main program.
Yes, sir. Yes, sir. Sure, sir.
Got it?
Yes, sir.
So like this, you have to take care while writing the functions. Okay.
Yes, sir. We will go for modifications more.
So after the number has been received by the main function, then main function can take the decision whether it is to be printed or whether it is to be stored in some file or anything, whether it is to be used in some processing. Okay.
Yes.
So that we have to leave it to the main function. Okay.
Okay, sir.
All right, otherwise it is good, no problem.
Oh, yes, sir. Yes, sir. I will just.
CI too.
Yes, sir. I need to go for load. Okay. Second PPT is visible.
Yes, it is visible.
Okay, you can start.
Go to next slide. So this is our second CIA, where we are going to see two problem statements. They are description and the results of Excel sheets, a blocked item of problem statement B, and conclusion. Next slide, please. So our first problem statement was given a system segment descriptor, find out segment base, segment limit, system segment, descriptor type, etc. Let's see first some theory, little bit of descriptor and about segment. So the object to which the segment selector points is called a descriptor. Descriptors are 8-byte quantities, that is 64-bit, which contains attributes about a given region of linear address space. And this attribute includes 32-bit base linear address of segment and 32-bit length and granularity of the segment. There are protection level, read, write, or execute privileges, and the default size of operands are 16-bit or 32-bit, and the type of segment. The Intel 386DX has two main categories, that are system segments and non-system segments, that are for code and data respectively. If the segment S bit is in the segment descriptor, it determines if a given segment is a system segment or a code segment or a data segment. If the S bit is 1, then the segment is either a code segment or a data segment. And if it is 0, then the segment is a system segment. And here in our problem statement, we are going to learn system segment descriptor and its type. So our S bit will always be 0, that is system segment. I request Aniket to take forward.
Yes, we have implemented. We can see here that this is the diagram for that. First of all, this is the segment base, then segment limits. We are more focusing on segment base, segment limit, and its type. So for segment base, this is the pointers, that is this 32 bits. Then here the base address is there, and here these three places where base address is there. So we have to take it from here, and for limits, these two are there where we can go for limit, finding the limit. And this is the type bit. If that S bit is 0, we can go for type of that segment descriptor, that is system segment descriptor. S equal to 0 indicates system descriptor. Here we can see that. So we have included which is here. So first of all, maybe it is, hope it is visible. This is what we have did. We have a separate color for each. For base, this is base. All are there in that green, somewhat green color. And for blue color, you can see that here we can, with the help of that blue, that yellow color, we can go for segment limit. And for that blue bit, that is S bit. S bit indicates that it is a segment or data segment. This system segment descriptor or data or code segment descriptor. So here we are, our statement is system segment descriptor types. So we are going for S is equal to 0 bit always. So first of all, we have calculated segment base, that is of the here, which is from here, that is 44 we can see here, as from this is the first bit AA, 99 is second bit, which is byte 1, as 88 is third bit, here is fourth bit, fifth bit. If we go from first, but if we go from as a standard convention, it says that we should go from 0. So 0th bit is AA, then 99, which is here. If whatever we can see here, it will automatically generate all the outputs by there, which we can see here at the bottom. So segment base, it will be calculated from that here in on the second line, the bits are starting from 4th bit. So this is 66 is the 4th bit, then 5th bit is 82, 22 is that 6th bit, and last bit is 44. So that 44 bit is there for segment base. Here 66 is there, and then we have to go for 77 and 88. It will calculate segment base. Then it will calculate limit. Here we have to take only one bit from here. That is here 2 bit is there. If we change that value, it will be converted here. And then that 99 and AA, these are the segment limit which we have discussed in our diagram also, and here also segment limit 15 to 0, it is 16 bit. And so then when I will just go for next snap. Hope this snap is visible, and this snap is for the type. Here you can see that we are using access write byte here for the type. So this is the 5th bit of that system segment descriptor. Here with the help of S bit, we can go for system segment or code segment. As we are going for that system segment descriptor, that S bit is 0, and then here whatever is the type, it will be in that column, that row, that cell, we can get it. Here 82 is there, so it will automatically generate here 2, and we can go for the 2 is LDT, so it is that type of system segment descriptor. If it is 0 or 8, it is invalid. And for A, it is not that Intel has reserved it, it is undefined. For TSS, there are 2 bits. One is for available 80286. For 9, it is 80386 available TSS. Like that, all the types are there. I request to I am going to share my screen here to show how I did here. Here is segment base. Hope screen is visible. Oh, that 82 is here. So here we are going to take that 2 from here, and here 8 we are going to generate with the advanced function. Here we can see int. It will convert that int C48. This is 82 is C48, we can see, and it will divide by 10, and it will be int. That will be converted to that. From that we can get that 8 bit, and other bit is 2, and that 2 bit is here, and with the help of that we can see that here 2 is for LDT, so it is of type LDT. If I change it to 83, maybe my rights are not, I'm not okay. Here we can see 3 if I go for, and so it will automatically how it will generate, I will change that value to 70. No, 7 we can go 4 1, and here we have to take 1. So it will automatically convert it to 4, and this one will automatically give the type 1, and 1 is available 80286. That's it from our Excel sheet or the first statement. So I request to go for second statement. I will just stop my presentation. I will decrease the zoom, and From the second statement, Arthak, go for it.
Good afternoon, all. My name is Murtaza Sathrajan. I will present the problem statement. They are the password-based door locking system using 8051. So the next, Aniket, next slide. So these are the table content. First one, introduction. A microcontroller-based door locker is an access control system that allows only authorized person to access a restricted area. The system has a keypad by which the password can be entered through it. When the enter password equal with the password stored in the memory, then the gate gets open. If you enter the wrong password, then the alarm is a switch on. This is the hardware requirement. First is the 89C51 controller. Second, 8051 programming board. Third one, programming cable. Fourth one, DC battery or 12-volt one adapter. Fifth one, 4x3 matrix cable. Next one, 16x2 LCD. Next 5 relay. Next DC motor. Next BC 547 transistor. Next where unit Krista, and next is the connecting wire. So the next, these are the software requirement. First is a Kale compiler, second is a FlashMagick, and third is a Protest. They are the software requirement. So to request Sandeep to brief explanation about the algorithm.
Thank you, Sarthak. Our question is password-based door lock system. We are see that of the algorithm of that system. First one, we have to initialize the declare that port 1 to LCD means that will be the our data pins that connects to the port 1 from 1.0 to 1.7. Then display the message enter password on LCD. It will be taken input from the user. Then now read the 5-digit password from the user. Here we have set password up to 5 digit. Compare the enter password with the stored password. It will be compared what will be the user enter the password. If it is equal, then it will be open. While not, if password is correct, then make P0.0 pin high and P0.1 pin low to open the door during time. Display door opening on the LCD. If our password is correct, then on the LCD it will be display door opening. Or if our password is wrong, then it display wrong password. It will be take some time to open the door. Next slide. Go to the next slide. Here is the our circuit diagram of the system. In that on the left side, that will be the LCD, microcontroller, keypad, and we have used resistor, relay, transistor, and DC motor. We have to initially first start from the LCD. Data pins D0 to D7, that will be the connector to port 1, 1.0 to 1.7, and control pins, that is 4, 5, 6, RS, RW, and E, that will be go to the P 3.5, 3.6, 3.7 respectively. Then next to the come to the keypad, there will be the 3 columns and 4 rows that will be connected to the pins P2.02, P.20, 2.1, 2.4, 2.5, 2.6, and And then pin number P3.0 will be connected to the register, and that will be connected to the transistor, and the end of the transistor collector end, that will be connected to the relay, that will be of 5 volt, and DC motor 12 volt, it connected to that relay. If the user gives correct input, then that relay and DC motor works, and our door will be open. Go to the next slide.
Yes, Sandeep, please tell sir that the disadvantage, one disadvantage that we use.
Yes, there will be the one disadvantage. If user forgot the password, then there will be not the case means forgot password. That time user can't open the door.
Now let's see some of the component details that are used in this system. So first is voltage regulator. A voltage regulator is designed to automatically maintain a constant voltage level. Depending on the design, it may be used to regulate one or more alternative current or direct current voltages. Next is stepper motor. It is a brushless DC electric motor that divides a full rotation into a number of equal steps. The motor's position can then be commanded to move and hold at one of these steps without any feedback sensor. Next is LCD, that is liquid crystal display. Its LCD screen is an electronic display module, and 16 into 2 LCD means it can display 16 characters per line, and there are 2 such lines. In this LCD, each character is displayed in 5 into 7 pixel matrix. This LCD has 2 registers, command and data respectively. And this is the last component of our system, that is momentary switch. So as we know that a switch is an electrical component that can break an electrical circuit, interrupting the current or diverting it from one conductor to another. The mechanism of a switch may be operated directly by a human operator to control a circuit. Now I request Shobham to take the explanation of further slides.
8051 microcontroller. The 8051 is an 8-bit microcontroller with 8-bit data bus and 16-bit address bus. The 16-bit address bus can address a 64K byte code memory space and a separate 20K byte of data memory space. The 8051 has 4K on chip with only the code memory and 1 to 8 bytes of internal random access memory RAM. Besides internal RAM, the 8051 has various special function registers such as an accumulator, A register, and the B register. And the many other control registers. Sandeep, please explain that.
Okay. There will be the pin 1 to 8, that will be the port 1, that does not serve any function. Pin 9, it is a reset pin, which is used to reset the microcontroller to its initial value. Pin 10 to 17, these are the port 3, that will be the serve functions, some like interrupt, timer input, control signals, serial communications. Pin 18 to 19, these are used for interfacing and external crystal to get the system clock. Pin 20 and pin 40, that will be the ground and VCC respectively, that will provide the power supply to the circuit. Pin 21 to 28, that will be the port 2, that serves input and output port. Pin 29, This is PSEN pin, which stands for Program Store Enable. It is used to read a signal from external program memory. Pin 30, it is a external access input. It is used to enable or disable the external memory. Pin 31, this is address latch enable. It is used to demultiplex the address data signal of port. Pin 22 to 39, these pins are known as port 0. It serves input output port at the lower order. And pin 10 to 70, that will not pin 21 to 28, that will serve the higher order address bus signals.
Advantage password-based door locking system. It's provided security, power consumption is less, use commonly available components, and it's easy and simple. Application of password-based door locking system. This is a simple circuit can be used at a residential places to ensure better safety. It can be used at organization to ensure authorized access to highly secure places like college. With a slight modification, this system can be used to control switching of doors through passwords. Conclusion of CI1 and CI2. We have successfully found segment-based address, segment-based limit, and segment and type of the system segment descriptor. We have deployed working door locking system using 8051 microcontroller. Here we conclude both the CI activities.
Thank you.
Thank you.
Okay, sir, we have concluded both CI activities. If any suggestions for second CI is there, we are ready to go for it.
Okay, students. Your both presentations are over, no?
Yes, sir, both presentations are over, but your voice is somewhat low, sir.
Okay, am I audible now?
Yes, sir, yes, sir.
Okay, so we shall start with the next presentations now. Next group presentation.
Okay, sir, should we leave?
Yeah.
Thank you, sir.
So whether next group students have joined?
No, sir, we have to, I will send the message to him.
Yes, Sai Sagar, are you from group number 6?
Yes, sir.
Who is going to upload PPTs?
Sir, Arpita.
Yes, ask her to join
Yes, sir. Yes.
immediately. Others also. Hmm? Yes, all of you should have been ready. Yes, have all joined or not? Who is going to upload the PPTs?
Hello, Arpita.
Sir, can we start?
Hello, sir.
Yes, Arpita, upload PPTs.
Hello, sir.
Upload PPTs. You have access to upload PPT.
Sir, how to upload?
There is a plus icon at the bottom left. Click on that. Upload presentation. Got it?
Yes, sir. Yes.
Upload presentations. A window will pop up. Select both the files simultaneously and upload
Yes,
both
sir.
files. Click on upload. All of you turn on your camera and start your presentation.
Sir, can we start?
Start.
Good afternoon to one and all present over here. Welcome to CIA1 presentation of microprocessor and microcontroller guided by Barbin sir. These are the members of our group. Next slide. We have included some content in this presentation: problem statement, introduction to interfacing of C programs with ALP, steps in program development, library function 1, inputs and outputs, library function 1, code, result function 1, snaps of out for various inputs, library function 2, inputs and outputs, library function 2, code, result function 2, snaps of out for various inputs, conclusion. Next slide. Problem statement: develop a library in 8086 family assembly language for following operation to be called from C language. Write help and suitable C programs to use these functions. Prepare a presentation on library developed with code and snapshots of the results. Submit presentation code and result snapshots. Use presentation and demonstration on library function developed. A. Compare to string. B. Read an integer in hexadecimal from keyboard. Next slide.
Kunal, check your audio. It is breaking. Rejoin your audio.
So, introduction to interfacing of C program with assembly language program. Subrouting invocation. Subrouting invocation. Now we are entering into the world of assembly language of 8086 family.
Yes, sir.
Microprocessor. So further discussion heavily depend upon it. Prior knowledge of 8086 assembly language is assumed. I shall give explanation as far as space constraint allows. Simplest form of subrouting invocation is call mnemonic. Note that stack frame is different for far call and for near call. Passing parameters. High-level language like C passes parameters on stack. Because each high-level language used memory in different ways, a common area is needed for subrouting. Interfacing. The accepted standard is stack. Mnemonic used to store 16-bit data on stack is push pop to retrieve data. Normally, if the parameter is a short numeric integer, its data value is pushed on stack. If the parameter is an alphanumeric string, a pointer to the string is passed. Floating point format number can be passed either by pointer or direct values. Please change the slide. Values are written by following ways: through the stack, through a register, through memory. None of these methods are automated, and we must predetermine which method we are going to use, and that must be pretty clear in assembly subrouting documentation. Turbo C follows following table to return values from a subrouting. Even function use ASM. The inline assembly directive must return their result as follows. So my friend will continue.
The table describes returning parameters from registers. Returning parameters from stack and fixed memory locations is also possible, but it is not practiced widely. In C, all general-purpose registers are considered volatile, and C program does not depend on the values stored in it. So here we have the table of the parameters and in which register it is returned. So in ordinal parameter is returned in AL 8-bit, AX 16-bit, DX, AX 32-bit. 8087 is returned in ST0 on the 8087's register stack. Pointer is returned in DSAX. Next slide. Steps in program development. Step 1. Steps for program development assembly language. Type the program in editor or notepad. Save the program with .asm extension. Run the program in DOSBox. Assemble the program by tasm file name.sm. Link the program by tlink file name.obj. For execution of program, file name. To debug, td. Give correct input and verify your output. At last, stop.
Languages. These languages use monomers or OP code to represent instructions. These languages are also machine specific. Next slide. Library function 1, input and outputs. In function name, function 1, short description of the function. In input, arguments, string to enter the string, outputs, returns. Compare to compare the two strings.
Here is a program to compare two strings. We have used macros to display the message at the output. It is a sequence of instruction and we have to repeat that task repeatedly. So we have used the macros to perform a task repeatedly. Then here we use the macro, and then the strings are there. This is a DOS interrupt function. Then endem means here the macro is end. Then data segment part is start. After that we have to display three messages. In that message first is for to enter the strings. Means here we are going to enter the two strings, and then if that strings are equal, then it will display the message as strings are equal, and if the strings are not equal, then it will display the message as strings are not equal. Here we use dollar symbol, which is to avoid the garbage values. So here we get us two strings. Then here the data part means this data segment is end here. So this is the end of data segment. Then the code segment is start. In that we have a compare procedure here. Then assume is as a assembler directory. And initially, when we want to compare the two strings, the counter is set to 0, and then we have to compare each character character by character of both these strings. So we have to increment our source index, which is the first character of our, which is point to first character of our string. And then this in this part the comparison will happen. So if the both strings are not equal, then it will jump to loop second, and if they are equal, then we have to increment our source index and destination index, and continue the loop first until the process is finished. Then this is rate is the rate is the last instruction of every procedure. So, and then compare this compare procedure we have started here, and here is the end of that procedure. Then on next slide. So here the when we enter the character into the string, so that data will be stored in accumulator, and then accumulator content will stored in the data segment part. Then it will display the message first, that is enter the two strings. Then we have to enter that strings, and this is for enter second string, means the second string will be contained in dx registers. Then here we have to increment our string characters one by one, and call the compare function to compare them. And here are the loops in which we are going to perform the comparison operation, and it will display the message 3, means here it will message 2, that is strings are equal, and if they are not equal, then it will go to loop 4, and it will display the message that strings are not equal. And here is the end of our code segment ends here, and this is the end of start. So these are the programs which we have executed. So in this, we have give the commands in the in DOSBox, and enter the two strings, that is good and god. Then it will display the message that strings are not equal. And similarly, if when we have entered the commands and enter the two strings, that hello and hello, then it will display it as strings are equal.
Library, function 2 input and outputs, function name, function 2, short description of the function, input arguments, hex to enter the hex digits, to return decimal to get decimal number at outputs.
So this is our program. In this, we have used model small, which tells that the assembler that to use the small memory model, means one is code segment, then a data segment, then stack segment, and these values of the segment registers are never changed. And when we use it, it allows us to write the instructions and return the instructions, that is rate. Then here we have used stack 100h, which is to reserve 100h bytes for stack. Then this is a data segment. This is a data part in which we have to first enter the hex digit, and then it will display the corresponding decimal. to display this.
You are not audible, Arpita. Rejoin your audio.
Am I audible now?
Yes, now audible.
Hello?
Yes, audible.
Here
now.
we initialize our, yes, sir. Here we initialize the data segment, and then data is stored in accumulator, and the accumulator contents will be moved to the data segment, and then we have to load and display that prompt one, means the message first that enter the hex digit A to F. Then here is the next procedure that this is a message to read the hex digit, and accumulator content will be stored in the base registers, and then we have to display the second message that the corresponding decimal digit, and then we have to go and then display the first decimal digit of that particular hex digit, and for that conversion part is here, that the convert the character into second digit, means from hex digit to decimal digit, and then here is a 4ch which return the control to DOS interrupt, and then main procedure, which our procedure name is main, so it is end here, that is end procedure, and we have end the main function. Then this is the result. Kunal will explain the result of that.
One minute. In this result, if we enter A in decimal, then it will only digit 10. If you enter P in decimal, then it will display that is 11. If we enter C, it will display the 12. Next slide. This will explain by Gaurav.
If we entered D, it will show 30. If we enter E, it will show 14. And if we enter F, it will show 15. Next. Conclusion. We understand the program of compression, expect in those programs and make. Next. Thank you.
Sir, how to go for second presentation?
Actually, you are not implemented them as a function. They are looking to be standalone programs. Have you passed parameters?
Miss, shall we execute it?
Oh, execute one.
Yes, sir. Sir, how to share?
At the bottom, there is a button to share the full screen. Bottom right.
Bottom right.
Beside the button to turn on the camera, there is one more button to share screen.
Yes, sir. Yes, find out. Entire screen, no?
Yeah.
Yes, yes. Is it visible?
Hello. It is screen is visible, but DOS box is not visible. Okay, now DOS box is visible.
Okay, sir. Colon. I have entered the command that is npm cd sum and my program. Then I have to enter link string.obj to create object file, then file name, string. Then it will ask us enter the strings. Means if you enter here any word like hello world, then it will display the message that strings are not equal, and if we enter the strings that is hello and hello, then it will display the message that strings are equal. Now if I want to
But you
go
are
for
not
next
using C
program,
program here, no? You are not using C program
sir,
here. Yes. Oh. Okay, now stop sharing screen. You can go for the second presentation.
sir, here we have that C programs with us.
Okay, that is not linked, na? Upload now the second presentation. Present it. Hello.
Yes, sir. Yes. How to share next presentation, sir?
Same way. Same procedure. Click on plus.
Plus icon is not there now. Let me refresh it. So that plus icon is not there. Hello? Hello, sir. Am I audible? Hello.
Yes, audible.
Plus icon is not there. How to present? Yes, now it is there. Is it visible now?
Yes, it is visible now.
Yes.
Yes, okay.
Sir, can you start? Hello, sir.
You are audible. Yes, yes.
Good afternoon to one and all present over here. Welcome to CI2 presentation of microprocessor and microcontroller guided by Barvin sir. These are the members of our group. Next slide. We have included some content in this presentation. Problem statement 1A. Description of concept in problem statement A. Result snaps of Excel sheet. Problem statement B. Description of solution for problem statement B. Block diagram for the problem statement B. Conclusion. Next slide. Problem statement A. Given base address, limit, type of system descriptor, etc. Find the descriptor. Next slide. This slide will explain by Akshay.
Description of concept in problem statement A. First, we'll know what is exactly descriptor. The object to which the segment select points to is called a descriptor. Descriptors are 8-byte quantities, 64-bit, which contain attributes about a given region of linear address space, that is a segment. These attributes includes the 32-bit base linear address of the segment, the 20-bit length and granularity of the segment, the protection level, read, write, or execute privileges, the default size of the operands 16-bit or 32-bit, and the type of segment. The Intel 386DX has two main categories of segments, segment system segments and non-system segments for code and data. The segment S bit in the segment descriptor determines if a given segment is a segment system segment or a code or data segment. If the S bit is 1, then the segment is either a code or data segment. If it is 0, then the segment is a system segment. The G bit or granularity bit specifies if a segment length is byte granular or page granular. Intel 386DX segments can be 1 megabyte long with byte granularity 0 or 4 gigabytes with page granularity 1. 220 pages each page is 4K bytes in length. The granularity is totally unrelated to paging. An Intel 386DX system can consist of segments with byte granularity and page granularity, whether or not paging is enabled. System segment descriptor format. System segment descriptor types. There are mainly two types of system segment descriptor, that is LDT descriptor and TSS descriptor. Further, Sai Sagar will be explaining.
So result snap of Excel sheet. This is the result we have get. So Arpita, can you go there to Excel sheet? So here is the system segment descriptor format where S bit is 0, so it is system segment descriptor. So so here we have given base address as 11 22 33 44H, which is in hexadecimal. Then segment limit from 0 to 19, which is 1 23 45H, where G is the granular bit 1, D is operator which is 0, AVL is available field which is 0, then type of segment descriptor which is LDT means 2. Here we have placed that base address limit, then segment in that format. So we have get the descriptor like Arpita, can you zoom it? Last part. Where descriptor we have get that 11 81 82 22 33 44 23 and 45. 6. So now my friend will continue after this.
A 8051 base system of your choice. Draw block diagram with appropriate sensors. ADC, EAC, input output devices interface with 8051. RFID security access control. Next slide. Table of contents. In first, introductions, block diagram, hardware components, circuit diagram, working principle, operation of RFID, security, access function, benefits, limitation, application, and conclusion.
Next slide will be explained by Kunal.
introduction, automatic identification and system has become necessary to overcome the security threats faced by organization. By installing the system at the entrance will only allow the authorized person to enter the organization. The system can also be installed at rooms inside the organization to restrict their access to sensitive areas in the organization.
Hardware components, 8051 series microcontroller, RFID readers, RFID tags, relay, relay driver IC, transformer, diodes, voltage regulator, resistors, capacitor, LED, and lamps.
So this is the circuit diagram of microcontroller. Next, microcontroller. Microcontroller may be called computer on chip since it has basic feature of microprocessor with internal ROM, RAM, parallel and series port within single chip. This is widely used in washing machine, VCD players, micro oven, robotic or in industries. Microcontroller can be classified on the basis of their bit process like 8-bit microcontroller or 16-bit microcontroller.
RFID readers and tags. RFID system can be classified the type of tag and reader. A passive reader active tag system has a passive reader which only receives radio signals from active tags. An active reader's passive system has an active reader which transmits interrogator signals and also receives authentication replies from passive tags. An active reader active tag system uses active tag open with interrogator signal from the active reader. Next slide. Here it is the block diagram of RFID security system. Here you can see the various type of components which is used in RFID security system. Transformer, rectifier, regulator, relay driver, display, RFID reader, relay, lamp. So let's see the working of each component. Relay. Relays are used where it is necessary to control a circuit by a separate low power signal. Solid state relays control power circuits, no moving parts, instead using a semiconductor device to perform switching. Magnetic latching relays require 1 plus of coil power to move their contact in one direction, another direction, electric pulse to move them back. Next slide. Transformers. The principal parts of transformer and their functions are the core, which makes a path from the magnetic flux, the primary coil, which receives energy from the arc source, the secondary coil, which receives energy from primary diodes. The 1N4148 is a standard small signal silicon diode used in signal processing. The 1N4148 is generally used in DO35 class package and it is very useful at high frequencies with reverse frequency time no more than 4 ns. This permits replication and duplication of radio frequency signals very effectively, as long as their amplitude is above the above forward conduction thresholds of silicon around 0.7 voltage, or the diode is biased. Next slide. It is the diagram of diode, which is a glass coated. Voltage regulators. A voltage regulator is an electronic circuit which maintains the output voltage constant in spite of changes within some specified limits in the load current, input voltage, temperature, etc. An IC-based voltage regulator can be classified in different ways. A common type of classification is 3-terminal voltage regulator and 5 or more terminal voltage regulator. Next. Resistors. Resistors are components used to resist the flow of electric current and have a stated value of resistance. Resistors can either fix or in value. Fixed resistors come in variety of different shapes, sizes, and forms. XL load resistors have a value resistance printed on them, or as you can see here the color coding. Next. Capacitors. A basic capacitor has two parallel plates separated by an insulating material. A capacitor stores an electric charge between the two. Next slide. LED. Applications of LED. Devices, medical applications, clothing, toys, remote control TVs, VCRs, lighting, indicators, signals, optoinsulators, and Next slide. Working principle. The aim of the aim of this project is designed to an RFID-based security access control system using 8051 microcontroller, in which only authorized personnel are allowed access to a secure area. When the circuit is powered on, the microcontroller will initially display a message as "swipe the card" on the LED display. When the RFID card on tag is swiped against the RFID reader, it will detect the ID card and send the unique card number to the microcontroller via serial terminal. Next. With the help of suitable programming, we need to compare the received card number with the number that already stored in the microcontroller. If the received number is matched with the already stored number, then the microcontroller will display the name of the card holder or the identification number of the LCD and activates the motor driver IC. As a result, the door is open for predefined duration, after which the door is automatically closed. If there is no match for the received numbers with the stored numbers, then the microcontroller will not open the door and displays a message as access denied on the LCD display. Next. Operations of RFID. The security and access control system is composed of two phases: the registration phase, recognition phase. In the registration phase, some images of the users are captured while issuing an RFID tag. The recognition phase comes when the user wants to enter the hostel. Next. The entrance and exit modules of RFID recognition for identification. While mesh module use RFID with a password to grant permission. These modules communicate with the computer system through a main controller. The data exchange between the main controller and computer system is through serial port, while parallel port data and control lines are used for handshaking purpose. Next. After detecting and receiving RFID tag data through a serial interrupt routine, microcontroller searches the NVRAM for this number. If no matches is found, the microcontroller makes an emergency call to the security when through GSM modem. At the same time, it turns on the alarm signal. On the other hand, if match is found, the microcontroller checks the entrance status of the user by scanning NVRAM. Next. Security access. RFID cards have been advertised as suitable for personal identification tasks because they are engineered to be tamper resistant. The chip usually implements some cryptographic algorithm. There are several methods for recovering some of the algorithm internal state. Differential power analysis involves measuring the precise time to electrical current required for certain encryption or decryption operations. Next. This can reduce the on-chip private key used by public key algorithm, such as RSA. Some implementations of symmetric ciphers can be very vulnerable to timing or power attacks as well. RFID cards can be physically disassembled by using acid, abrasive, or other some techniques. No obtained unrestricted access to onboard microprocessor. Although such techniques obviously involves a fairly high risk of permanent damage to the chip, they permit such more detailed information to be extracted. Next. Functions will explain by Kunal.
Entrance monitoring controller, exit monitoring controller, mesh monitoring controller, computer system, and web server. Next slide. Benefits: enhance safety and security, portability, reliability, reconfigurable, and reusable.
Limitations. Even though the RFID technology is secure, the security can be increased by integrating other security measures like facial detection, fingerprint sensor, etc. As the card details are stored in the microcontroller, only a limited number of card details can be stored. This can be increased by implementing like next slide. Applications are designed as the system uses RFID based identification. It can be used to access secure areas like research centers, defense sites, etc. It is low power system, and also the RFID cards or tags used are of passive type. Next. And conclusion, design of our security and access control system for use of using data application with market technology and system compromise the security and access processing information from subcontractors. Thank you. Hello, sir. Sir is in meeting.
Okay.
We can leave.
Yes, sir.
Thank you, sir.
Thank you.
Thank you, sir.